Okay, so I wanted to do a little run through of how to graph a function. So just a quick little process so we can maybe see it and make sure we're all on the same page there. So let's say that I was asked to graph something like 5 secant of pi over 2 x minus 1 plus 3. So there's two components to our graph, right? We have the horizontal, which is the x, which is the inputs, and we have the vertical, which is the y, the outputs. So we need to consider both of these when coming up with our graph. And I accidentally erased secant right there. So the first thing that I do is think of the the horizontal part. Now, between vertical or horizontal, it does not make too much of a difference whether you approach first, but I just do the x component first. So I look at the inside of our function there. So to that end, the first question that I have is just what is the period of the function? I go out from 0 out to the period, and then I try and fill in the 3 spots on the inside. But I need to know what the period is. Well, there is one number in the function that tells us what the period is, and that's this number, what I often call the frequency. Now, the new period of one of our weird functions here comes from the original period of the function divided by this frequency. Well, in this case, secant's normal period is 2 pi, and in this case, the frequency is pi over 2. So my new period in this case is equal to 2 pi divided by pi over 2. Well, dividing by a fraction is multiplying by the reciprocal. So I'll just change to multiply and I'll flip that fraction. So here, my times pi and divide by pi should cancel, leaving me with 2 times 2, which is just 4. So that tells me that my period here is just going to be 4. So I am going to write out from 0 to 4 because that is the period that I found here with this formula. So once we clean this up, and again, you want to show your work, so don't erase your work, but I'm drawing on a whiteboard with limited space. Okay, so once we know that our period goes all the way out to 4, then I want to fill in all the spots between. Well, first, I mark at 0, and then I want to go halfway between these, so I'll take half of 4 is 2, half of 2 is 1, and then the third spot is just going to be 3 times that spot, so 3 times 1 is 3. So this is how the spacing on the x component of the graph works. But it's not just that we do some kind of horizontal stretching. We also have one other thing happening horizontally, what we call the phase shift. So remember, the sign, SIGN, of your phase shift is really the opposite of what direction you're going in. So in this case, we would say there is a phase shift of 1. We would say we are moving to the right by 1 because it is a minus 1 in there. So to move all of our numbers to the right by 1, we have to add 1 to each of these values. So this line becomes 0 plus 1 is 1, 1 plus 2 is 2, 2 plus 1 is 3, 3 plus 1 is 4, and 4 plus 1 is 5. Now it's worth noting that all we did was scoot over. This distance, this period, is still the same value. This period is still 4. We just moved over. So that is actually all that we need to do for the x components so far. So now that we know where 0 is, I can go ahead and put my numbers down here. Because we like to draw the y-axis through 0, it may not necessarily be a demand but it certainly helps makes things a little bit easier. Now, this graph, all that's left to do is our vertical components. Well, that happens with this vertical shift, tells us our midline. So if our vertical shift is up 3, then the middle of our graph is going to happen at 3. So let me maybe do this dotted line in a different color. If it lets, it's not letting me change color. Okay, so we know that this line is going to go through 3. That is our midline. So our function is going to almost focus or sit in the middle of 3. Or, sorry, 3 is going to be in the middle of our function, should be the better way of saying it. Well, this number out here is 5, and that is our vertical stretching. So that means that instead of normally, we only go up 1, down 1, now we're stretching by 5. So we're going to go up 5. And so because in the middle we're 3, to go up 5, we go 1, 2, 3, 4, 5. Sure. And this should be 8. And then we go down 5. 3, 1, 2, 3, 4, 5. Wait, I can't count. Yeah. 1, 2, 3, 4, 5. Sure. Yeah. Oh, I see the mistake I made. I wrote the wrong number of ticks right there. There we go. Okay. So now we go from 3 all the way down to -2, and from 3 all the way up to 8. Now, so far, nothing has been special about the fact that this is a secant function. Why? Well, because when I graph secant or cosecant, I'm just going to pretend like I'm graphing sine or cosine until the end. So the key detail to point out is which function are we going to put down? Well, that's just the function that we are the reciprocal of, the one it's related to. So if we remember, sine is 1 over, well, maybe we write this the other way. 1 over sine is cosecant, and 1 over cosine is secant. So which function do I want to look at, sine or cosine? Well, that would be cosine, because this function is secant. So I am just going to graph cosine like normal. So now I start at 1, and sorry for the cut. I realized that I just made a mistake when I tried to graph, but I kept going, so I'm having to go a bit back. So again, we're wanting to graph cosine because the function that we're dealing with is secant. So I remember that cosine starts at the top. Well, I want to emphasize I'm not starting my function at 0 anymore. I am drawing my function between this period that I picked out before. So even though I marked where 0 is on the graph, that's just to be clear of what I'm really trying to draw. But what I really care about writing down is this period from 1 to 5. So cosine is going to start at 1, again, because this is the period that we picked out earlier. Some of the points got erased. So we're going to start at 1, and then we hit the middle at the next point, so our midline. Then we hit the bottom at the next point, so all the way down to -2. Then we're back at the middle at the next point, and then we finish back at the top where we started. So this is just that shape for cosine. Well, then the next question is, what do I do to get secant from just having this graph? Well, I have to remember that I have asymptotes for secant, just like cosecant, just like tangent and cotangent. We have asymptotes. Our asymptotes always just happen wherever we cross the midline. So once I make this graph, all I have to do is see where I cross the midline and draw my asymptotes there. Then secant just kind of bounces off of cosine. So I'd love to draw that in another color if it gave me the chance to, but we're just kind of flipping cosine. And that is all that really goes into making my graph of secant. I just did everything as if I was doing cosine, and then I just flipped the graph that way. Okay. All right. So this time I want to graph a tangent function. So let's say I had 3 tangent of 5x minus pi plus 2. So I'm going to go just like I did before, and I need to figure out what the period of tangent is. We remember period is equal to the basic period divided by our frequency. Well, in this case, we're looking at a tangent function whose basic period is pi. And in this case, our frequency is 5. So in this function, the period is pi over 5. So I want to draw my x-axis for tangent. Now, tangent is the only weird function where instead of just drawing from 0 out to your period, tangent kind of sits in the middle. So instead of our function starting here and then doing its stuff out to its period, tangent starts in the middle. Tangent starts right here, almost, and at 0, and then it has stuff happening on both sides. So to that end, hopefully that wasn't too confusing. Instead of drawing our period from 0 out to some point, out to our period, we start with 0 in the middle and split our period on both sides here. So because I'm splitting my period in half, all I'm going over here, instead of doing pi over 5 out on the right, I'm doing pi over 10. And then this halfway point is half of that, so pi over 20. And then the negative side, we don't have to think too hard, is just going to be the negative of those two things. Very good. So that is just the basic process for trying to graph our period there. Well, just as before, we're not done because, well, with the x component at all, because we still have what we call a phase shift. Now we remember, because there's a minus sign right here, the phase shift is to the right, which means I'm going to move all of these numbers to the right. So how do I move a number to the right by pi? I add pi to each number. Also to 0. So my new period, I can do a little bit of quick math and say that, well, pi is equal to 10 pi over 10 and is equal to 20 pi over 20. So when I add this across, pi plus 10 pi is 10 pi over 10 pi plus pi over 10. So that's going to be 11 pi over 10, 21 pi over 20, 0, and now over here we're subtracting this difference. So this should be negative pi, sorry, what in the world? I need to learn to use undo instead of erase. We're doing negative pi over 20 plus 20 pi over 20, and this is 19 pi over 20. I had to double check my work there. So this is 19 pi over 20, and then this should be 9 pi over 10. Now, hopefully y'alls don't have numbers that are as gross as these, but if you do, then it's okay. Worst case scenario, also I made a mistake. 0 plus, what in the world? 0 plus pi is pi. There we go. Okay. So worst case scenario, if you're not sure how to simplify something like this, then you just leave it as pi over 10 plus pi. That's not a big deal. It's still the same number. Okay. So we have figured out where our period for tangent happens from 9 pi over 10 up to 11 pi over 10. Very good. So now when I want to make this graph, I need to figure out the y components. So here I have a vertical shift up 2 and then a vertical stretch of 3. So I hear a lot of police sirens. So I'm going to go ahead and put the x coordinate down and then the y direction as well. I don't know why I do it like that. Hold on. Okay. So let's just say pi is here, and then we have 11 pi over 10, 21 pi over 20. It's got erased. 19 pi over 20, and then 9 pi over 10. Now for the y component, because we're having a vertical shift up 2 in our function, instead of tangent kind of sitting right in the middle at 0, then now in the middle it's going to be up 2. So I can write this dotted line to let you know that that is the midline. So tangent normally sits at 0 right in the middle. So because we're going up 2, then this midline is at 2. We're right at the midline in the middle of our function. Well then, because our vertical stretching is 3, I'm going to mark up 3 from 2 and get 5. And then I'll go down 3 from 2 and get -1. So now my asymptotes are always going to be on the edge there. And I remember that tangent goes up on the right side and down on the negative side. So the intention is that I kind of meet -1 at this point and +5 at this point, because normally this would be 1 right here, and this would be -1. And in this case, we're still -1 just because of the coincidence. But all that to say, we're kind of just using our vertical stretching to know where these points should go. Now that we have the graph, I want to point something out. Tangent sits entirely between these lines, right? So in this case, the distance from this line to this line better be pi over 5 if we do the math. Hopefully I did the math correctly, fingers crossed. But if I didn't do the math correctly, well, then we can double check. That period should be the distance. What in the world? Should be the distance between the two edges. So the distance from 9 pi over 10 to 11 pi over 10. And I can do, my pizza rolls are done. That's the alarm. Ignore me. We can do 11 pi over 10 minus 9 pi over 10 and get 2 pi over 10. And it turns out that 2 pi over 10 does simplify 2 pi over 5. Perfect. So I did do that correctly. All right, so that's graphing tangent, and then double checking that I actually did do the math correctly by checking that period there. Okay, very good. So that's it. I don't have a good ending for the video. Goodbye.